next row? It all depends on this. No tricks. What's that row going to be? How far out do we got to go for this here? Remember, that's rho squared. Rho squared equals 16, just the distance out what? 4. That's what's going on in that shaded region. In that entire shaded region, you're always going from 0 to 4. Those are your limits. That's easy. Well, here's the challenge. What is this? I say we'll label this. Make sure we don't mess this up. You know, is that 0 to pi over 2? Is that 0 to pi over 4? Is that pi over 4 to pi over 2? Is that pi over 2 to pi? You know what I mean? So let's label this. What's phi equal to right here? Phi equals 0 up there. What's phi equal to right there?
Pi over 4.
Pi over 4. So that's definitely got to be one of our limits. What's phi equal to right there in the xy plane?
Pi over 2.
There you go. We just figured out the limits. Excellent. We're going to go from, look, pi over 4 to pi over 2, all the way around. What brings it all the way around? The theta. The theta will just swing it. Isn't that cool? The theta swings it all the way around. We're going from pi over 4 to pi over 2. We put the lower limit there. Cool. You don't have to work this out. It was just a setup problem. You'll find the volume, that'll be the setup. But I know you can do this integral. Look, break it up like we did before. The key is, can you set that thing up? I know you can solve all these. We'll solve one of them though. We'll eventually do another one. Evan, great job with that. And when I want to switch this up and do a problem like that last one on here, the wording has changed slightly. Okay? Find the volume. Use spherical coordinates to find the volume of the solid that lies, this time, within sphere. That was the wording. Isn't within the same thing as inside? Good. Within the sphere, I'm going to use the same 16. Does that sound good? No, let's do that one right there. Let's use a 4. Use the same one on that sheet. Above the x-axis, but this time above the surface of the cone. Same equation. So that gets a whole new setup. But it's not much different, is it? There's my sphere. There's my cone. And where am I shading? Within the sphere, here's the sphere, above the xy plane and above the surface of the cone. Okay. Above the surface of that cone. Where am I shading?
Above.
What does this look like?
Pizza pie.
It's like an ice cream cone. Yeah, right. Because it's three-dimensional. I'm thinking, right on, it's like an ice cream cone. That's what it looks like. It's got this thing, and it's all the way around, right? It's got that little ice cream on top. Because it's within the sphere, but above, there's the surface of the cone right there. It looks like a V when I'm drawing it on the board, but it goes all the way around. All right, so what do I get now? What's theta? Still the same, 0 to 2 pi. We'll come back to phi. What will rho be? What's that radius?
2.
Oh, 0 to 2, 0 to 2, 0 to 2, 0 to 2, 0 to 2. This is going from 0 to 2. And they said volume, so I'm just doing rho squared sine phi as my volume element. D rho d phi d theta. Cool? What's phi? Pi over 4 to pi over 2. 0 to pi, pi over 2 to pi, 0 to pi over 4. Let's go through this again. What's phi equal to right here?
0.
Right. Phi equals 0, positive x, and then it opened up. And it stopped right here. What did phi equal there?
Pi over 4.
You got it. You understand spherical coordinates. Outstanding. I can tell. You got it. 0 to pi over 4. That would give us the volume of that ice cream cone. Cool? This is way easier than, imagine doing that in Cartesian, that's what we're saying. That would be a pain. Right? You can still do it, but it'd still be a lot of work with you'd have radicals. You'd have radicals going on. You'd have that radical, but you'd have more radicals with that top series. We can work this thing out. Let's work that out. This time we'll solve it. This time we'll solve it. Alright, can I break it up?
Mm-hmm.
Let's do it. 0 to 2 pi, it's k be there. You got a 0 to pi over 4 sine of phi. Okay, that shouldn't be too bad. And then a 0 to 2 over rho squared. That should be easy. That's rho cubed over 3. Oh, that's 8/3. This looks like the problem we did earlier. 0 to 2 pi, that's 2 pi. Looks like the problem we did earlier. What's this though?
Negative cosine.
Okay, the only thing is, you're going from 0 to pi over 4 this time. Anybody know the cosine of pi over 4? It's got a radical 2 in it.
Root 2 over 2.
Root 2 over 2, or 1 over root 2, whichever way you want to say it. I'll do root 2 over 2 because you said that. I'm going to do negative root 2 over 2
Plus 1.
minus negative cosine of 0 is.
1.
So what's another way to write that?
Plus 1.
So negative root 2 over 2 plus 1. I can't simplify that. So I did like common denominators. I've got this times that. That's my volume. I'll leave my answer like that. The volume equals 2 pi times 8/3 times 1 minus root 2 over 2. Unless you want to make the 2 times the 8 what?
16.
16/3 pi. If you want to distribute it, you can knock out that 2, but this is fine. You know? 2 pi times 8/3, 16/3 pi times 1 minus root 2. That's your volume of the ice-cream zone. Cool? And you got it. I get worried about not number 3, number 4. So I'm going to write it on the board. You see number 4? On the practice problems that I handed out today. I try to really make it really big, bold-faced print. They go, hey, what's the integral of this? They just didn't say anything about volume. They said evaluate this integral. X squared plus y squared plus z squared. Okay. Where E is the solid, there's E. E is the solid. X squared plus y squared plus z squared. If it's a solid, they gotta use an inequality less than or equal to 1. And I didn't want your eyes to miss this. Comma. Don't see that? What does that mean?
Well,
If our eyes miss this, we're going to set up the problem incorrectly. That means this solid has to be above the what?
XY
XY plane. Okay? Has everyone got that? So if our eyes missed that, I just didn't want that to happen. So do you all have your problem sets handy? Did I have, look near the end. I don't remember. Well, not 22, not 23, 24. I would like everyone, if you have it with you right now on 24, highlight it or circle it. Do you see that z greater than equal to 0? It's small. It's like, this, if your eyes miss that, you're going to be choosing, the wrong answer. I'll wait till you get there. 24 in the problem set. Yeah. Let's see it. Just highlight it. Hey, don't worry about it. There's a little beep, and you, oh, that means I'm not going all the way down. It's like I'm stopping above the XY plane. That's what that means, above XY plane. Cool. All right, so everyone, we just got to set this thing up. We're going to evaluate this integral. E is a solid. X squared plus y squared plus z squared less than or equal to 1. Hey, does this have anything to do with that? No, it just so happened that they had that in it. So we're going to go with spherical coordinates. So I'm going to start out. What's automatic? Rho squared sine phi, right? This is the first problem of the day. I've got something else in here. I can't leave it like that. I'm not allowed to need x, y's, and z's. I need rho's and thetas and p's. Anybody know what that's equal to? That's rho squared. So I'm just going to go in there and go, ah, you're rho squared. Isn't that cool? That's rho squared. Is the automatic volume element, a d rho, d phi, a d theta. And we're talking about a full sphere, but the sphere is above the xy plane. Everyone got that? Full sphere above xy plane, oh, hemisphere. A top hemisphere with a radius of 1. So let's start with rho. You know what that is? 0 to 1. Okay, we got that. What's this then? What's phi? That's the tough one. Above xy plane. 0 to pi, is that pi over 4, pi over 2, or pi?
Pi.
You're good, that's 90 degrees. We're going from 0 to pi over 2 to get down to the xy plane, right? To give you that hemisphere. Or do 0 to pi. That's the answer. What's this? Nothing different here. If they said like first octant or something, we do 0 to pi over 2, but this is going, theta is going all the way around. So theta is going to stay what? What do you think theta like that? There's a setup. You can split this up thing also, right? Rho to the 4th. What's the integral of rho to the 4th? Rho to the 5th over 5. What's the integral of a sine phi, negative cosine phi? Plug in pi over 2 and 0. 0 to 2 pi. Hey, great job with that. Let's do number 5. Can I raise? Cool. Yeah, all right, it's number 5. Let me write all this out. So we're going to find the mass of a solid. Okay, this time it's not volume. You agree, when we find mass of a solid, it's a triple integral and we need the density. So they're going to give you the density. The only thing is, you'll notice they'll give the density in a different Greek letter. They used to give it in rho. So we'll just put it in, something. You'll notice the notation is something different. Mass of a solid. Solid region between spheres. X squared plus y squared plus z squared equal to 4. And what's the other one? X squared plus y squared plus z squared equals 25. Ooh. This would be really challenging in Cartesian coordinates. This should be a piece of cake in spherical coordinates. And what's the density? Where the density is, okay, they use the Greek letter sigma there. Sigma equals, this is the density, xz. Alright. Are you ready? What's the automatic volume element?
Rho squared sine theta.
Rho squared sine b. Rho squared sine b. A d rho. A d phi d theta. Well, I'm going to put that way down here. My d rho d phi d theta. You know why? Where's this going? That goes in here, right? But this is wrong, isn't it? I leave it like that. That's an x, that's a z. My variables are rho, phi, and theta. What was x equal to? Better leave yourself enough room here. Remember these are long? What's x?
Rho sine theta.
It's long, look at it, right there.
Sine phi
Rho
cosine.
sine phi. Alright, here we go. This is that x. I'll draw an arrow. Rho sine phi cos theta. And what's z?
Rho sine.
Z is rho.
Sine phi sine theta.
Remember, z is just rho cosine phi, though, right?
Oh, so this
Rho cosine phi.
Z, yes.
Yeah.
I say y.
Right. But if they had a y, I would have put that. I would have put that. There was a y in there. Like if it said x, y, z, it didn't say that, did it? No, if it said X, Y, Z, this thing would have been even longer. I would have had to include that long Y. Now, what's the limits? I hope you find this easy. If it's between those two spheres, what's the radius of those two spheres so I can get the rows? Radius is
2.
2, and what's this radius? There you go. Between a sphere of 2 and a sphere of 5. Yeah. The region inside. Did they say anything about above XY point? No. So B gets to go what? Let it open up to get the full spheres. From 0 to
Pi.
pi, theta. They didn't say anything about the quadrants, right? They didn't say about like only an octant 1. If they said octant 1, then we're doing 0 to pi over 2. This is just full 1. And we can definitely make this look a little prettier, right?
What if they said like octant 2 to 3?
Oh, I like that. Octant 2 to 3. Octant 2 to octant 3. That would be, this octant 1's here, we'd go from pi over 2 to the pi. That would mean over there. That means on that next door over on that side. And they never do that if you're curious.
All right.
They either do octant 1 or they say above XY plane or they say below XY plane.
All right.
I know, it's a good question. They'll never do like octant 7 or something, right? Man, excellent. Excellent. Any questions on that? Okay, cool. And I'm going to put this back, 0 to 2 pi. Hey, the book, I wanted to show you this. The book had a question. It's going to look something we did similar here. They had an image, and they wanted you to set up a triple integral to figure out what it would be. So I'm going to put that up here. I'll let you copy that. I just want everyone to see this.